Events were unfolding over the European continent, disturbing the tranquility of the night. Amidst frontline operations, accompanied by smoke, a low roar of engines was detected over the territory. Observers noted the appearance of a massive object in the sky, slowly moving towards the horizon. This event marked the beginning of a new phase in warfare, the era of airship deployment. These steerable balloons, filled with hydrogen, represented a significant technical achievement of the early 20th century, demonstrating humanity's ability for controlled flight in airspace. With the outbreak of a large-scale conflict in Europe, military engineers, including Russian ones, carefully studied foreign developments. The Russian Empire's own balloon units had been developing since the late 19th century. Observation balloons were already used during the Russo-Japanese campaign, but by this time, the military leadership faced the task of creating a steerable airship capable of performing tasks on par with German Zeppelins. The chief engineer of the Russian Empire's air fleet, Captain Kovanko, recognized that the side which first mastered the airspace would gain an advantage in observation, artillery fire adjustment, and striking the enemy's rear. By the outbreak of the conflict, Russia's industrial potential did not support the mass production of airships, but the country possessed the necessary specialists and a desire to develop this field. The first airship hangar was built in Gatchina, and a special airship team was formed under the military department in St. Petersburg. This unit employed engineers, officers, and mechanics who were involved in the development and implementation of steerable flight projects. By the time the Empire entered the war, its arsenal included the Albatros, Krechet, Condor, and Sokol airships, non-rigid airships designed for reconnaissance and artillery fire adjustment. Despite their smaller size compared to German apparatuses, they demonstrated operational reliability and low maintenance requirements. The initial tests were carried out in a short period. In the autumn of 1914, the Albatros airship performed a flight over the front line near Warsaw. The apparatus's crew observed the movement of enemy formations and transmitted data to artillery units. The apparatus's operational range was limited, but the achieved results were deemed successful. For the first time, aerial artillery fire adjustment was carried out in real time. This flight demonstrated the potential of airships in providing aerial observation for ground forces. During the same period, German apparatuses carried out bombings of cities such as Antwerp and Paris, whereas the apparatuses of the Russian Empire were primarily used for reconnaissance operations and supporting ground units. The leadership of the Russian Empire's armed forces viewed airships not only as an indicator of technical progress, but also as a means capable of enhancing the safety of personnel. On the Eastern Front, which was characterized by a significant length of the battle line, airships proved to be an effective means for observing enemy movements, especially in the hard-to-reach areas of Polessia, over swamps and frontline roads. Engineering units were developing new approaches. In Petrograd, under the leadership of engineer Bakhchivanadze, improved gas equipment was created, allowing for faster hydrogen inflation of the envelope and increasing the readiness of the apparatuses for flight. Airships began to be used during both daytime and nighttime hours. Night flights required high qualifications from the crews. In the dark, the apparatus was controlled by compass and visual landmarks. The slightest spark could lead to a catastrophe. By the middle of the war, engineers of this region had achieved significant results. In Gatchina, a new hangar was built, housing the airship Griff, the largest of the local airships of that period, with a volume exceeding 15,000 cubic meters. It could ascend to a height of more than 2,000 meters and remain airborne for up to 10 hours. The crew consisted of 6 people, a commander, a navigator, 2 mechanics, and 2 observers. Griff was used on the northwestern front, where it assisted in adjusting artillery fire during the siege of fortified positions. However, every sortie remained a difficult trial. The airship represented a large and vulnerable target. In clear weather, it could easily be detected from the ground, and anti-aircraft batteries opened fire. Crews of local airships demonstrated great endurance and determination. A record has been preserved stating that during one of the sorties near Vilno, the airship Sokol sustained a puncture in its envelope, but the crew managed to manually seal the gas leak and continue the mission. For these actions, the crew was nominated for awards of the Orders of St. George. In the Imperial Army headquarters, the possibility of using airships for bombing was discussed. Experiments were conducted at an airfield near Pskov for dropping small caliber bombs from mechanical holders. Although the effectiveness of these strikes was limited, their psychological effect proved significant. The enemy, detecting the hum of the airship overhead, often abandoned their positions. During this period, German Zeppelins were already carrying out raids on London, while officers of this state sought to demonstrate that local airships were capable of performing not only reconnaissance, but also combat missions. The approach of this empire had distinctive characteristics. Airships were considered not as a means of indiscriminate destruction, but as a tool for precise strike and observation. The head of state, Nicholas II, personally showed interest in the state of the air fleet. A record of his visit to the Gatchina airfield has been preserved in archival documents, where he inspected the airship Krechet and held a conversation with the commanders. The head of state noted that such apparatuses should become not the eyes but the mind of the Army, emphasizing the importance of science and calculation in their application. Meanwhile, the intensity of hostilities increased, anti-aircraft guns were perfected, and fighter aviation actively developed. Aircraft with incendiary bullets appeared in the sky, posing a danger to hydrogen apparatuses. Every airship sortie now required a well-thought-out plan, an evasion route, and reserve landing sites. Local engineers sought methods of protection. Ideas were proposed for replacing hydrogen with a less dangerous gas, strengthening the structure with a light metal frame. However, the technical capabilities of the empire were limited, and the implementation of many projects was delayed. Nevertheless, airship units continued to function. On the northern front, airships patrolled the Baltic coast, where the enemy undertook reconnaissance flights. Temporary hangars were created in Arkhangelsk and Riga, and masts were built for mooring the apparatuses. In one mission, the airship Condor detected the movement of enemy ships off the coast, which allowed the fleet to timely adjust its patrolling. Such operations demonstrated the airship's ability to perform tasks unavailable to airplanes. Long periods of airborne operation, work over water expanses, and providing communication between ground and naval forces. Crews, including officers, skilled in operating airships under difficult conditions were highly valued. According to the memoirs of Griff airship commander Captain Polyansky, every takeoff and landing constituted operations of increased complexity. There was an understanding of the high risk of the apparatus catching fire in case of an error. Nevertheless, the execution of tasks continued. There was a conviction that aerial technology played a significant role in the outcome of military operations, and the airship was regarded not only as a means of reconnaissance, but also as an indicator of technological potential and determination. By the end of 1916, despite the difficult situation on the fronts, the Russian Empire preserved and developed its airship units. A number of airships were modernized. Their volumes and flight range were increased, and new Argus and Mercedes engines, acquired through allies, were installed. Cases were noted of airships performing flights to deliver dispatches to headquarters even in conditions of snowfall and icing. These flights were recorded as a demonstration of the crew's ability to perform tasks under difficult conditions. Engineers and officers of this state, despite limited production capacities and resources, demonstrated the effectiveness of airships as a serious military tool and a reliable scout. The accumulated experience served as a basis for further developments and was utilized in subsequent periods when the need for aeronautical apparatuses arose again. By the beginning of the 20th century, airships had definitively transformed from technical experiments into instruments of military purpose. In Europe, a competition unfolded between engineering schools where each state sought to demonstrate the superiority of its airships in terms of characteristics, altitude, and power. Germany focused on the industrial production of rigid airships, Zeppelins, while France preferred fast and maneuverable, non-rigid airships. The Russian Empire chose the path of developing its own design solutions, integrating foreign experience with national approaches. After a series of successful reconnaissance missions, the command of this state decided to include airships in the regular air forces. The Directorate of Aeronautical Troops was created under the main directorate of the General Staff, under whose control specialized workshops for airship construction began to operate. Unlike Germany, which had dozens of specialized enterprises, this country had a limited number of production sites, but compensated for this with the level of calculations and the quality of engineering training. The main aeronautical center was located in St. Petersburg, where non-rigid airships were produced for reconnaissance and observation tasks. During this period, Engineer Lieutenant Shablovsky presented a project for a semi-rigid airship with a light metal keel, the purpose of which was to increase the structural stability at altitude and improve maneuverability in windy conditions. The military department showed interest in the project, and by the spring of 1915, the first prototype was assembled in Gatchina. Simultaneously, in European countries, work was underway to increase flight altitude. The German side proceeded from the principle of evading the enemy by gaining altitude. Their airships reached marks exceeding 4,000 meters, while those of the Russian Empire were for now limited to 2,500 meters. In demonstrations held in Petrograd, balloons with flags and banners were used, and the press published articles titled "The New Masters of the Sky." However, military operations demanded practical effectiveness, not a show of force. The command of the Western Front initiated a request for the development of an airship capable not only of conducting observation, but also of striking railway junctions and depots. This marked the beginning of the development of the Astra apparatus, the first airship equipped with a bombing system created in Russia. The Astra project was completed within a tight time frame. The experience of French designers was taken as a basis, however. The whole structure was strengthened, and the apparatus was equipped with domestically produced engines. The airship had a volume of approximately 16,000 cubic meters and could carry up to 500 kilograms of cargo. In the spring of 1915, the apparatus made its first combat sortie over the area known as the Polish Front. The target was the supply station of the opposing side. Bomb release was carried out manually by means of lever mechanisms, achieving high accuracy. 2 ammunition trains were damaged. This event became the first documented combat success of an airship developed in Russia. During the same period, the German side, developing its production, focused its efforts on the development of Zeppelin-type airships of the LZ series. Their apparatuses demonstrated a tendency towards increasing size. Volumes were 20,000, 30,000, and subsequently more than 30,000 cubic meters. They could carry 1.5 tons of bombs and operate at a distance of up to 600 kilometers. However, intensive development was accompanied by negative aspects such as frequent accidents, fires, and explosions upon landing. Observers from the Russian Empire recorded these incidents and formulated appropriate conclusions. It was decided not to strive for gigantic sizes, but to develop medium-sized apparatuses with increased survivability. Engineers in Russia carefully studied reports coming from the front line. For example, Captain Rojdestvensky pointed out, "Not the volume in cubic meters, but the skill of the crew determines the outcome of the flight." This position reflected an approach characteristic of the aeronautical school in Russia. In Gatchina and Pskov, commander training programs were initiated, within which future pilots were trained in navigation, meteorology, and working with radio stations. Radio communication became the main advantage of airships over ordinary balloons. This allowed observers to transmit target coordinates in real time, significantly increasing the accuracy of artillery fire. Against the backdrop of these achievements, the concept of integrating airships and aviation emerged. Airships were intended for use as bases for light reconnaissance aircraft. Similar projects were also discussed in Germany, but it was in Russia that the experimental deployment of a glider from an airship was carried out for the first time. This event took place in the summer of 1916 in the Vilno area. Although the test was not a complete success, the idea was recognized as promising and included in subsequent developments. Meanwhile, the situation on the front lines demanded increasingly active participation from aeronautical units. In late 1915, airships began to be used in the Black Sea coast area. They accompanied ship convoys, patrolling areas around Sevastopol and Odessa. Representatives of the officer corps of the Russian Empire realized that an airship was capable of performing the functions of a scout cruiser, possessing a wider field of view, greater range of action, and immeasurably lower costs. The commander of the Black Sea Fleet, Admiral Eberhard, stated in his report that one airship could perform the work of 2 light cruisers with a 4-fold reduction in costs. Special attention was paid to gas production. In wartime conditions, hydrogen was a scarce resource. Special installations were used for its production, which were delivered directly to the front line. Chemical units were operating at aeronautical stations responsible for producing gas from sulfuric acid and iron filings. The process was characterized by increased danger and required strict adherence to rules. Despite recorded incidents, production was maintained as the lack of gas rendered the airship non-functional. In 2016, the use of airships by the armed forces of the Russian Empire reached its maximum level. Up to 20 apparatuses of various types were operating, organized into aeronautical divisions. Their tasks included reconnaissance, artillery fire adjustment, and transportation. On the northern front, airships were also used for evacuating the wounded from hard-to-reach areas. The use of these apparatuses provided an overview of the terrain, which was inaccessible from ground positions. Amidst the developing confrontation, German Zeppelins increased in size and flight altitude, which was a measure to avoid anti-aircraft fire. Engineers of the Russian Empire responded to this by improving the envelope design, installing more powerful engines, and optimizing aerodynamics. In Riga, a new type of triple-layered rubberized envelope was developed, demonstrating increased resistance to punctures. Tests confirmed that in the event of bullet hits, gas loss occurred slowly, providing the crew with an opportunity for rescue. By the end of 2016, the headquarters of the Aeronautical Forces was considering a project for creating a long-range airship intended for operations over the Baltic Sea and escorting the naval fleet. The project envisioned equipping the apparatus with 4 engines and a range of up to 700 kilometers. The start of construction coincided with a period of significant challenges for the country. Work on creating the apparatus continued. Against the backdrop of a prolonged military conflict in Europe, the airships of the Russian Empire continued to perform their assigned tasks. These apparatuses were not used as a strategic means of aerial attack, unlike some types of German Zeppelins, but served as reliable means for supporting Army operations, providing extended observation, improved fire accuracy, and assistance in decision-making. Developers demonstrated a commitment to the advancement of aeronautical technologies, continuing to improve designs even under unfavorable conditions. By the beginning of 1917, the nature of aerial operations had changed. While previously airships performed patrols with minimal risk, by the aforementioned period, each mission had acquired the character of a high-risk combat sortie. The opposing side developed effective anti-aircraft defense systems, including the emergence of high-speed fighters. Despite this, the aeronautical units of the Russian Empire did not reduce their activities. On the contrary, airship activity reached its maximum level. On the Eastern Front, they were employed along the entire length from the Baltic states to the Carpathians. Airship operations were particularly intense in the northwestern direction. Airships of the Griff, Sokol, and Condor types carried out regular reconnaissance flights, detecting enemy artillery positions and monitoring railway junctions and supply columns. In March, the airship Sokol conducted observation in the area of the Nauru River. The crew recorded significant enemy troop movements and transmitted the information to headquarters. Several hours later, an artillery strike was launched at the specified coordinates. The targets were hit and enemy forces abandoned their positions. This incident demonstrated the capabilities of adjusting artillery fire from aboard an airship in the absence of other aircraft. Over time, the airspace became more perilous for operations. German fighters began regular patrolling of the front, tracking slow-moving targets. One such incident occurred in the summer of 1917 when the airship Astra was conducting a reconnaissance flight in the Baranovici area. At an altitude of approximately 2,000 meters, it was attacked by a single enemy aircraft armed with incendiary ammunition. The commander of the airship, Captain Kornilov, gave the order for an immediate ballast jettison to gain altitude and simultaneously opened fire with a Lewis machine gun. For several minutes, a combat engagement ensued between the hydrogen-filled craft and the maneuverable fighter. One of the incendiary shells pierced the airship's envelope, but no fire occurred. After a brief combat engagement, the enemy aircraft retreated, and the damaged airship Dirigible returned to base. This incident was recorded in reports as an example of the crew's ability to operate under combat conditions. Concurrently, night operations by airships commenced. Night conditions provided the airships with the opportunity to approach closer to the front line to drop bombs on enemy depots and crossings. For such flights, devices with phosphorus illumination and special compasses were installed on the airships. On the night of July 17, the airship Cretchet ascended over the Vilna direction and carried out a raid on an enemy ammunition depot. The explosion was registered as powerful. It was heard at a distance of tens of kilometers. The crew returned without casualties. This was one of the first confirmed night sorties, which concluded with the achievement of its objective in the history of airship deployment by this contingent. Combat experience accumulated. Commanders began to employ new tactics, using cloud cover as concealment, descending after a raid under the cover of smoke screens, and altering return routes. Despite the technical superiority of enemy aviation, airships demonstrated significant survivability. Machine guns were installed on them, their suspended gondolas were reinforced, and their envelopes were covered with several layers of fabric. These works were performed at frontline airfields by crews in field conditions. During the period when Zeppelin-type airships were used for attacks on urban targets, the described airships were employed on a different principle. Their objective was military installations and communications. In the spring of 1917, the airship Griff participated in an operation near Pinsk, where the enemy had concentrated reserves. The apparatus ascended at night and dropped several dozen small bombs on the crossing. After the explosions, the bridge was destroyed, which delayed the movement of troops for almost 24 hours. The front commander noted the crew's role in his report and emphasized that the airship had proven itself to be a precise and economical means of destruction. Nevertheless, losses began to be recorded. An incident resulting in losses occurred near Riga when the airship Orel was shot down by anti-aircraft battery fire. The hit struck the central compartment, which contained the fuel tanks. The apparatus caught fire, but the crew attempted to make a landing. 3 crew members perished. The others survived and were decorated. Circumstances provoked a discussion about replacing hydrogen. However, no safe alternatives existed under combat conditions. Despite the difficulties, units operating airships continued their activities. In conditions of resource scarcity, they became centers of ingenuity. Radio stations were repaired manually, and the skin was restored using available materials. To maintain the apparatus's balance, sandbags suspended on ropes were used, which allowed for mass adjustment during flight. Operations over maritime areas acquired special significance. Along the Baltic coast, airships interacted with naval vessels, performing reconnaissance and searching for enemy submarines. This marked a new stage in warfare, as airships were used for maritime patrolling for the first time. Thanks to their significant flight endurance and low speed, they could monitor the situation in coastal waters for several hours, transmitting information to ships. Such missions significantly increased the fleet's effectiveness, especially in foggy conditions over the Baltic Sea. By the autumn of 1917, airships had become less common on the front line. Wear and tear on equipment, a shortage of gas, and domestic political events in the country almost led to a cessation of production. Nevertheless, even during this period, individual crews continued to serve. Their apparatuses ascended over positions, observing retreats and providing cover for withdrawing troops. By the spring of 1918, airships had lost their dominant position in the airspace. Enemy anti-aircraft defense reached a level where every flight involved significant risk. Along the front line, anti-aircraft batteries, searchlights, and specialized acoustic detection systems were deployed, making it possible to pinpoint the apparatus's approach before it emerged from the clouds. At night, searchlight beams pierced the sky, making the airship a distinct target in their light. Crews developed countermeasures. Dark coatings were applied to the envelopes, and gondolas were covered with materials that absorbed light reflection. Some apparatuses were equipped with primitive smoke generators to create a masking cloud. However, the primary protective measures remained silence and altitude. Commanders raised the machines to the maximum possible altitude, striving to remain outside the engagement zone. This required a high level of skill and self-control. Engines operated at their limits, and every gust of wind created a threat of losing control. At the same time, enemy aviation began to employ specialized patrol groups for intercepting airships. Light fighters ascended at night, orienting themselves by the noise of the engines. When encountering the enemy, airship crews opened retaliatory fire from their onboard machine guns. However, the advantage remained with speed. Instances of aircraft falling became frequent. With each passing month, the risk increased, and only a small number of apparatuses returned to base without damage. Against this backdrop, naval airships demonstrated greater resilience. They performed operations over the Baltic and Black Seas, where the threat level from anti-aircraft fire was lower. Here, the airships continued to conduct reconnaissance and escort convoys, assisting the fleet in detecting enemy submarines and ships. Their value was determined by their ability to stay airborne for extended periods and monitor vast maritime areas. Representatives of the fleet's high command indicated that one airship could perform the functions of several reconnaissance ships. Nevertheless, technical and organizational difficulties were increasing. Hydrogen production was declining, engines were subject to wear and tear, and spare parts had to be obtained by dismantling damaged airships. By the summer of 1918, it became evident that the continued operation of the Russian Empire's airship fleet was impractical. Some of the airships were transferred to the naval fleet, while the others were dismantled. The crews were reassigned to aviation units. This period marked the end of the active operation of combat airships. Despite their displacement by airplanes, the accumulated experience was unique. The activities of the aeronauts demonstrated that a combination of discipline, precise calculations, and readiness for risk could offset certain technical shortcomings. Although the names of these specialists were rarely mentioned in official reports, their actions contributed to the development of aerial operations for subsequent generations of aviators within the empire. By the autumn of 1918, the airships of the Russian Empire were approaching the end of their service life. Military actions had depleted the country's resources, leading to empty hangars and the sequential shutdown of hydrogen stations. Out of several dozen airships, only a few remained in active operation. The crews recognized the ultimate dominance of airplanes in the airspace, yet continued to carry out reconnaissance and patrol missions, utilizing remaining fuel and gas supplies. The last actively used airship was the Griff, based in the Petrograd area. Its crew conducted a final flight in September, performing a reconnaissance mission over the coast of the Gulf of Finland. Despite the intensifying wind and a loss of pressure in the envelope, the commander decided not to return until the assigned task was fully completed. Upon the airship's landing, the engine was functioning at minimal revolutions, and the outer skin had significant damage. This flight became the last for a combat airship of the Imperial Fleet. After the cessation of hostilities, some specialists transferred to aviation, while others directed their skills to civilian projects. However, the contribution of the first aeronauts remained documented. They were among those who first operated steerable airships within the Russian Empire, demonstrating that a combination of determination and an engineering approach allowed for the use of even relatively simple materials in the air. This is a narrative about the stages of mastering airspace, which occurred during the formation period of military and civil aviation.